Hello guys, welcome back to this new video. In this video we will be discussing about compiler design new topics. So first of all we will see what are the classifications of context-free grammars, then we will see what is an ambiguous grammar. So starting with the classification of context-free grammar, we will see that what is it. So it can be actually classified based on the two properties, that if the number of string that it generates is having finite number of strings or it is having infinite number of strings. So if it is having finite number of strings, then the CFG, that is the context free grammar, is non-recursive, and it is also known as non-recursive grammar. And if the context free grammar can generate infinite number of strings, then the grammar is said to be recursive grammar. So during the compilation, the parser will use the grammar of the language to make a parse tree out of the source code. Okay, and that must be an unambiguous grammar, and an ambiguous grammar must not be used for any parsing. So as ambiguous grammar is not good for any parser, so we will discuss about it after this topic. So the second thing on which the CFG is classified is based on the number of derivation trees. So if there is only one derivation tree, then the context-free grammar is unambiguous, and if there are more than one derivation trees, then the context-free grammar is ambiguous. So let's see some examples of recursive grammar and then of some ambiguous and unambiguous grammars. So starting with this, you can see this example that S derives S, small a, capital S, and capital S derives V. So the language, that is the set of strings that this grammar will actually generate, is shown as like this: a, b, a, b, b, a, b, a, b, like this. So this is a kind of infinite grammar, right? And now let's see on this thing. So S derives a, and then a derives a, b, or c. So this grammar will also generate an infinite number of strings, that is CA, CBA, CBBA, like that. So we must also note that if there is a recursive context-free grammar and if it contains no useless rules, then it will necessarily produce an infinite language. Okay, now coming to the non-recursive grammar. So an example can be S derives A and A derives B or C. So only these two strings can be generated via this grammar, that is B, A and C. So this is a finite grammar and it is also known as non-recursive grammar. Okay, now there are also types of recursive grammars. So there is a left recursive grammar, right recursive grammar, and a general recursive grammar. So basically left recursive grammar means that the tree that actually is generated via these grammars will have a left skewing, and right recursive grammar, we will have right recursion that will result in the right skewing of the parse tree or the tree that is generated by this grammar. And general recursive grammar having general recursion, that it doesn't depend on only left or right, it can be either left for some time then right, or either right for some time and then left. Now we must also note that a linear grammar is a context-free grammar that has at most one non-terminal in the right hand side of each of its production. So this is one thing to be noted down. Okay, now coming to the ambiguous grammar. So as we discussed here in a very brief thing, that if there is only one derivation tree, then the context-free grammar is unambiguous, and if there are more than one derivation tree, then the context-free grammar is ambiguous. So as we know that like context-free grammars are classified based on the number of derivation trees and number of strings. So depending on the number of derivation trees, context-free grammars are subdivided into two more types, that is the ambiguous grammar and unambiguous grammar. So let's talk about the ambiguous grammar now. So a context-free grammar is said to be ambiguous if there exists more than one derivation tree for the given input string. So more than one leftmost derivation tree or rightmost derivation tree. So leftmost derivation tree, like let's see a proper definition that actually we need to know, but it you should only like understand what it is, because these definitions will not be actually asked, but you should know how to read them. Okay, so now coming to the definition of this ambiguous grammar. So let we define G containing VTPS, which is a context free grammar, and it is said to be ambiguous if and only if there exists a string in T star that has more than one parse tree. It is to be noted that there exists a string, that is only a string a string that has more than one parse tree is only required to prove it as an ambiguous grammar. Okay, and where v is a finite set of variables, t is a finite set of terminals, and p is a finite set of productions of the form a derives alpha, where a is a variable and alpha belongs to v union t star, and s is a variable of the start symbol. Okay, like you can see an example. Let's say we have this production given, so e2 e plus e or id. So if we want to derive a string that is id plus id plus id, so we can have two derivation trees based on, if we use leftmost derivation, then we can get two parse trees for this grammar. So you can see that these parse tree always lead to id plus id plus id, but still there are two methods from which we can derive this string. So both the above parse trees are derived from the same grammar rules, but the both parse trees are different, hence the grammar is ambiguous. So let's see another example where set of alphabets is 0 to 9 plus star brackets. Okay, so derives I, e derives I, e plus e derives e star e, and e derives bracket e close bracket, and I derives epsilon 0 1 dot 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 or 9. Okay, so let's see if we want to derive 3 star 2 plus 5. So we can do it in two ways as shown here. You can pause the video and see, for the first leftmost derivation we can see how we derived this, and by the second leftmost derivation we can also see that it derives like this. So it is also an ambiguous grammar. Okay, and some of more examples of ambiguous grammars are these. You can pause the video and see them. Also, the following grammars are unambiguous because these derives only one parse tree. Okay, so now coming to the inherently ambiguous language, let L be a context free grammar, and if every context free grammar with the language L equals to L G is ambiguous, then L is said to be inherently ambiguous language. Okay, and ambiguity is a property of grammar and not of languages. Okay, this is an important thing, and ambiguous grammar is unlikely to be useful for a programming language because of two parse tree structures for the same strings that gives two different meanings to the program, so the compiler will get confused whether to go with the first parse tree or the second parse tree. So we can actually eliminate this by reviewing the ambiguity, and these can be done via different methods like rewriting the grammar, if there is only one derivation or parse tree possible for a string, and one method can be like removing the left recursion and also removing the left factoring. So we will discuss about them in the next video. Till then, keep watching and keep learning.
Anchor.